first topic today, electrolysis. Now be a good boy and study for mommy. To sum up electrolysis, we need to dive into what actually is electrolysis. Well, that's what mommy is here for, so don't you worry and pay attention. So listen closely, my sweet, obedient little pup. Kneel and listen while mommy weaves every single one of your commands into one perfect lesson on electrolysis. Electrolysis is the ultimate act of domination. We take a quiet, unwilling compound, water, copper sulfate solution, molten sodium chloride, whatever dares to resist, and we force electricity through it until it breaks and obeys. We connect a power source, drop 2 electrodes into the electrolyte, and make the anode surrender electrons while the cathode greedily accepts them. Nothing happens unless we command it. The reaction is non-spontaneous, so it only kneels because we shove the current in and refuse to let it say no. In pure molten sodium chloride, there is no water to interfere, so the cathode produces glistening liquid sodium metal, and the anode releases pale green chlorine gas. Clean, brutal, absolute separation. In aqueous copper sulfate with inert graphite electrodes, copper ions are dragged to the cathode and played out as shiny copper metal, while water itself is ripped apart at the anode, releasing oxygen gas. Sulfate ions simply watch, too proud to oxidize, switch to copper electrodes, and the anode sacrifices its own copper atoms to the solution, so the cathode can grow fatter. Mass lost at the anode exactly equals mass gained at the cathode. Perfect controlled transfer. Come closer, my little pup. Mommy is going to take you so much deeper now that every breath you take will taste like ozone and molten metal. Imagine the chloralkali membrane cell, the modern cathedral of industrial domination. A river of saturated sodium chloride solution is pumped between 2 chambers, separated by a thin, unforgiving ion exchange membrane. Titanium anodes coated with ruthenium and iridium oxides face one side. On the other, nickel cathodes wait like patient predators. When we unleash the current, chloride ions march to the anode and are stripped naked. 2 chloride ions forced to become 1 chlorine gas molecule, rising in perfect green obedience. Meanwhile, water molecules at the nickel cathode are torn apart. Hydrogen gas explodes free, and hydroxide ions are born. Sodium ions slip through the membrane like collared pets, allowed only one direction. And when they meet those newborn hydroxide ions, they form concentrated sodium hydroxide solution. Nothing is wasted. Chlorine, hydrogen, and sodium hydroxide, 3 obedient products from one act of domination. Deeper still, the downs sell for sodium metal. A steel tank filled with molten sodium chloride at 800 degrees Celsius. A central graphite anode rises like a dark throne surrounded by a circular steel cathode. Current surges. Liquid sodium metal forms at the cathode and floats upward into a collection ring because it is less dense than the molten salt. Chlorine gas is sucked away from the hooded anode. To keep the newly born sodium from ever meeting its chlorine again, a steel gauze diaphragm forces them apart, eternal separation enforced by design. Even deeper, electrowinning of zinc from zinc sulfate leach liquor. Giant cells the size of swimming pools, lead silver anodes alternating with aluminum cathodes. For 7 days, we pour hundreds of amperes per square meter through acidic solution. Pure zinc grows in thick, flawless sheets on the aluminum. Then workers rip the cathodes out, strip the zinc like peeling perfect skin, and send the blank aluminum back for another cycle. The anodes slowly dissolve, releasing silver ions that keep the oxygen overpotential high, so the process stays profitable. Every gram of metal is owned before it even exists. You're trembling now, aren't you? Good boy. Mommy can feel how deep this has gone into you. My obedient little pup. Mommy is going to paint this picture slowly and perfectly for you. Imagine a beaker filled with pale blue aqueous copper Roman 2 sulfate solution. We lower 2 electrodes into that cool, waiting liquid and turn on the current. When the electrodes are inert graphite or platinum that will not give themselves up, copper ions feel the pull instantly. They march straight to the negative cathode, press against its surface, and are forced to accept 2 electrons each. The moment they do, they surrender their charge and become soft, rosy copper metal that clings and grows thicker with every heartbeat of current. Copper plates out there because copper ions love gaining electrons far more than water molecules do. Water never stands a chance against them. At the positive anode, sulfate ions stand proud and refuse to lose electrons. Water itself has to step forward and submit. Water molecules are torn apart. Oxygen atoms pair up and escape as colorless oxygen gas that bubbles to the surface, while the leftover hydrogen ions drift away into the solution. Water is chosen because it is weaker and easier to oxidize than sulfate. Now change only the electrodes, make both of them pure copper metal, and watch the game shift. The cathode still hungers exactly the same way. Copper ions arrive, accept electrons, and played out as fresh, gleaming copper, making that cathode heavier and more beautiful. But the anode is copper now, and it has no choice. Its own surface atoms are ripped away one by one. Each copper atom on the anode loses 2 electrons and dissolves back into the blue solution as copper ions. The anode grows thinner, lighter, eaten alive by the current it is forced to feed. Copper dissolves there because copper metal is far easier to oxidize than water or sulfate. The anode sacrifices its own body to keep the circuit obedient. In the end, every atom the anode loses is reborn on the cathode. The solution stays the same perfect blue, but copper has been moved exactly where Mommy commanded it to go. You absorbed every word so perfectly, my good boy. Mommy is very, very pleased with you right now. Now, my sweet, attentive little pup, it's time for you to speak for Mommy. Imagine a beaker filled with aqueous sodium chloride solution, ordinary salt dissolved in water, and we are using inert graphite electrodes. Tell me clearly, what substance is made at the cathode, the negative electrode, and in what form does it appear, metal, gas, or solution? Unpause the video once you have completed this task for Mommy. Now for the second question. What substance is made at the anode, the positive electrode, and in what form does it appear, gas or something else? Unpause the video once you have finished for Mommy. Now those answers better be right, pup, or Mommy will be very disappointed in you. What a shame. But I know you answered right for Mommy, so tonight I will pull you close and let you feel just how proud you've made me tonight.